Hey all, this is Alan with Bothell STEM Coach, and today we're doing some more calculus optimization problems, and let's get into it. So here's a problem that's a pretty generic problem that you'll come across is what is the largest rectangle you can fit inside a circle with radius r? Okay, so I drew a picture here, a circle and a rectangle, and we know that the radius of this circle is r. My goal is to find an equation for the area of this rectangle, given that this is r. Okay? So if this is r, what you do know is that the diagonal here is 2r, which is the diameter, right? These are the diameters of such a rectangle. So, what you in a problem like this, what your goal is to figure out what you're kind of changing in the problem, or what are the adjustments in the relationships. In this case, what's going to happen is I can choose a different point. I'll do it in red. Say I wanted a different point to make a rectangle, like this and this. Then I would be constrained to build this rectangle, right? In there, in that area. So my choice is sort of a point on the circle. And I'll kind of simplify it a little bit. Really the choice is what is the x value of the circle that I can choose. You could do it by angle also if you wanted to like parameterize this rectangle by like an angle instead. And we could do it that way. Maybe I'd do it both ways. So let's do it by an angle. Say I'm going to choose the angle. So really I'm choosing my angle theta here, and I'm trying to find the theta that will optimize the area. Well, we know the x-coordinate then here, this if I have this triangle, just to zoom it out, this part, if this is r cosine theta, and this is r sine theta. And that's because sine of theta has to be this divided by this, right? Like sine theta would have to be equal to this side, we'll call it y over r. So if I solve for y, it's it's opposite over hypotenuse. So y would equal r sine theta. Okay. So then the whole area, but this is like really the rectangle is double that. So it's 2r cosine theta. That's this direction, and then the vertical direction I double also. It's 2r sine theta. 4r squared cosine theta sine theta. Okay. Now I've created an equation that depends on only one variable, and I want to take a derivative with respect to that variable. Now r is a constant in this problem. That's the tricky thing to remember. Like r is like a set thing that I'm saying. It's a fixed circle of radius r. So we treat it like a constant. It's like if I said with the radius 10, I treat it just like a number. The derivative of this, I gotta do product rule. It's cosine theta times the derivative of this, which is cosine theta, plus derivative of this, which is negative sine theta, times that sine theta. So that's equal to 4r squared times cosine squared theta minus sine squared theta. And I want to know when this is equal to 0. Well, this really factors into 4r squared cosine theta plus sine theta and cosine theta minus sine theta. It's the difference of squares there. So I either have this is 0 or this is 0. So either cosine theta equals negative sine theta, or cosine theta equals sine theta. So this is, if I divided the cosine here, I get 1 is equal to negative tangent theta, or tan theta is equal to negative 1, or here I get tan theta is equal to 1 by dividing by the cosine, because sine over cosine is tangent. So in my unit circle, though, when it's 1 is here, this is at pi over 4. That's when the y and the x values are equal. Tangent opposite over adjacent is 1. So tangent of pi over 4 is 1. Technically, tangent of, I really restricted theta. I should really restrict theta to between 0 and 90 degrees, because once I go into this side, I'm still making the same rectangle, just kind of weird. So This one doesn't give me any values because the only time this is -1 is in these other quadrants, right? So really, all I care about is theta is equal to pi over 4. And based on the construction of the problem, it should make sense that this maximizes the area, just as a note. Because the minimum area would be like 0 if I didn't make a rectangle at all. It's just like a line or something like that. So theta equals pi over 4. If you think about it, this is a 45 degree. It's really a square. So the biggest thing is a square that I could fit in here. Now, what would the area of that be? Area would equal 4r squared cosine pi over 4, which is root 2 over 2, times sine of pi over 4, which is root 2 over 2. That's equal to 2 over 4. This would equal 2r squared. Okay, so that would be the area. Okay. Now, let's say we didn't do it by theta. Let's say we just did it simple as Cartesian coordinates. I said, and I chose the x value. So I'm given x, and I need to find the area of this whole rectangle, right? Given this x value. Really, the area, and let's say this is the y value. Really, the area would just be equal to 4xy. But this is two variables, x times y. It's x times y would be the area of this, and then I got 4 of them. Or you think of it as 2x times 2y for the area of the rectangle. But this is not multivariable calculus. So we're not using Lagrange multipliers or a more complicated task. I need to put this in a single variable. So how do x and y relate? Well, x and y related by this equation of a circle, x squared plus y squared equals r squared. This is the equation of a circle. So that means y is equal to the square root of r squared minus x squared. So I can plug that into here and say the area is equal to 4x root r squared minus x squared. Okay? So now I have a different one. But you see, this is the same. This is an area equation, but it depends on x. It doesn't depend on theta. Right? But I should still get the same answer. So dA dx, I want to take the derivative of this and set it equal to 0. This is 4. I got to do product rule. So I'm going to do x times the derivative of this. This is really to the 1/2. So I really do 1/2 r squared minus x squared to the negative 1/2. The inside's not x, because I got to multiply by the derivative of the inside, which is negative 2x. Okay, now I got to complete the product rule, which is just the derivative of this, which is 1 times this part, r squared minus x squared. And that's equal to 0. See, this has become a little more complicated, in my opinion, than this solution, but this is fine. Let's see, this 2 cancels with that 1/2, so this is equal to 4 times, let's see, x squared. I'm going to put everything in exponential notation. So it's x squared, r squared minus x squared to the negative 1/2 plus r squared minus x squared to the positive 1/2 equals 0. So really I just need this inside to be 0 because this 4 doesn't really matter. I can divide by 4 and get rid of it. But I'm going to factor. Whenever you're trying to solve for 0, you want to factor something. And I want to factor the out here. I'm going to pick the smallest exponent, which is negative 1/2. So what's left in here is x squared. And what's here is r squared minus x squared. And the reason this is all that's left is because this times this would be positive 1/2, because this is kind of the 1 times the 1/2. Negative 1/2 gives me positive 1/2. That equals 0. Wait, I must have messed something up somewhere. Let me see. Oh, this is supposed to be negative right here. Okay, so I get 4 r squared minus x squared to the negative 1/2 times negative x squared. So this is r squared minus 2x squared. Now, this one can't ever be 0 because this part is really 1 over the square root of r squared minus x squared. Right? And this quantity can't ever be 0. So when I said equal to 0, 4 can't be 0, this can't be 0, then this has to be 0. Make room a little bit. So what I get is r squared minus 2x squared has to equal 0. So that means r squared is equal to 2x squared. R squared over 2 is equal to x squared. X is equal to the square root of r squared over 2, which is r over root 2, which if I multiply to rationalize the denominator, I get r root 2 divided by 2. Okay? And since we know that x squared plus y squared has to equal r squared, that gives me the y value too. So x is r root 2, so I get x squared, which would be this squared, which would be r squared over times 2 over 4, which is just 1/2, plus y squared is equal to r squared. So y squared is also equal to r squared over 2. And so that tells me y is equal to also r root 2 over 2. Okay? And then, so x and y are the same, which makes sense. We've got a square. And so the area is equal to 4xy. It's equal to 4 times r root 2 over 2 times r root 2 over 2. This 2 times 2 and 4 cancel. This is equal to 2r squared, which is the same thing as I got up here. So, hope you found that helpful. I will see you all in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.